Hey guys, this is Mr. H. Hey, I wanted to do a video on rational versus irrational numbers. I'll be honest, on the benchmark, the students who tried rational versus irrational, a lot of them missed that question. So I wanted to go over this again, and I'm hoping that if you watch this video, that what you need to be able to do is clear, and you'll be able to get these kind of questions if you see it on the Regents. All right, so the very first thing, I want to go over this, and I can't say this enough. Basically, what you just need to do is you need to be able to look, whoops, I don't want to do that. You just need to be able to look, and you need to be able to determine if a number is irrational, because if it's not irrational, then it must be rational. So these are the two conditions that you need to be looking for. One, it needs to have, the number has to have decimals that go on forever. So that's the first condition. So if the numbers don't go on forever, or if it doesn't have decimals, then it's rational, period. All right. The next thing is, even if the decimals go on forever, they cannot have a repeating pattern. Okay, so it has to have decimals that go on forever. That's one. And it cannot have a repeating pattern. So if those two things are true, then the number that we're dealing with is irrational. Now, everything else that we see in this class will be rational. Everything else is going to be rational. So you just need to be able to look at a number and say that's irrational or it's not irrational. If it's not irrational, then it must be rational. Okay, so let's just look at a couple examples. All right, so this one says, what is the product of the square root of 1,024 and a negative 3.4? Is that going to be rational or irrational? And they want us to explain our answer. Now, the way that I want you guys to do this is just write each number. And by the way, in order to answer this question, you got to know what product means. And product just means that you are multiplying. So we're going to multiply these two. Now, once you do that, let me go get my calculator because I need that. Okay. So now I'm going to do menu 15, get rid of all of this stuff, control, delete. Now, all you're going to do is you're going to look at each individual number and find out if it's irrational or rational. So I'm just going to do the square root of 1,024, press enter. That's 32. It doesn't have any decimals. So if it doesn't have decimals, then I know this is going to be rational, period. It's a rational number. Now, look at the next one, a negative 3.4. Well, it has a decimal, but it doesn't go on forever. So if it doesn't go on forever, then it's not irrational, which means it must be rational. Now, all we're going to do is we're going to take these two numbers and we're going to multiply them together. And then whatever the number we get, we're going to look at that number and see if it's rational or irrational. So I took the two numbers, I multiplied them. I got a negative 108.8. And this has a decimal, but it doesn't go on forever. So this is also a rational number. So our final thing, we should just say a rational number times a rational number gives us another rational number. That's 2 points, period. We're done. Let's look at another question. Now, this was the one that we had on the benchmark. And as I said, most of the students who attempted this question did not get it right. So let's do it. So very first thing you should do is write the number. And since it's the product, we're going to be doing multiplication. And we have two numbers here. We have the square root of 16 and we have the fraction 4/7. So we want to know if we multiply those two together, is it going to be rational or irrational? So same thing. Let's start with the square root of 16. Press enter. It tells us that the number is 4. It doesn't have any decimals. So we know that this is a rational number. Square root of 16 is a rational number. And if you want to know the reason, is 16 is a perfect square. And whenever you take the square root of a perfect square, you always get a rational number, period. Now, 4/7. What about that? Is that rational or irrational? Does it have decimals? No, it doesn't. It's a fraction. It doesn't have any decimals. So we should say, oh, that's rational. Now, that's the definition of rational, by the way. It's a ratio of two integers. 4 is an integer, 7 is an integer. It's the ratio of two integers. Any number that's the ratio of two integers is a rational number. Now, but let's say you guys don't remember that, or you're looking at like this fraction, you're not sure, put it into the calculator and see if it makes a decimal. So if I go 4 divided by 7, and now, you know, if you want a decimal, you put a decimal there. A decimal has to be an enter in the number, and then press enter. Now, so let's look at this closely, because I said that this is a rational number, and that means that it has to either has to have a repeating pattern. So if you look at this number, you can see that it goes on forever. The question is, does it have a repeating pattern? And the answer is, it absolutely has a repeating pattern. So if you look at this, it goes 5, 7, 1, 4, 2, 8. And then it starts over again, 5, 7, 1, 4, 2, 8. And then it starts over again, 5, 7, 1, 4, 2, 8. Now the calculator can't display all of the digits, so it truncates it, but this part is repeating, this part is repeating, and this part started repeating until the calculator cut it off, but it's a repeating decimal. So if it's a repeating decimal, then it must be, let me clear this, and then it must be a rational number. So even if you couldn't look at 4/7 and say, oh, that's a fraction, so it must be rational, even if you put it into the calculator and looked at it closely, you can tell that it has a repeating pattern. Now, let's see. I'm going to control clear this. And so now I'm just going to take those two numbers and I'm just going to multiply them, because that's what the product means. So that's what I'm going to do. I'm going to multiply them times 4 over 7. And then I go enter and I get 16/7. That is a fraction. It's a rational number. If we make it into a decimal, it's the same thing, divided by 7 point, right? We get this. If we look at this closely, and I'm going to bring this up so you can see it, this has a repeating pattern. Again, if you look at this, it's 2, 8, 5, 7, 1, 4. Then it starts again, 2, 8, 5, 7, 1, 4. And then it tries to start over and it rounds it since there's no more, but this is repeating, this is repeating, this is repeating, and it started with the first number. This should have been a 2, by the way, but since it's at the end, it just truncates it. Actually, it rounded it from a 2 to a 3, but this should have been a 2, this should have been an 8. This is definitely repeating. So let me clear this, do this, and yeah, that's the answer. So again, you could write rational times rational equals rational. Boom, we're done. Okay, I'm gonna do this one. All right, so if you look at this, they give us two numbers, square root of 363 and 27. So what we're gonna do is we're gonna look at each one of those numbers and we're going to see if they are rational or irrational. So I'm just going to put the square root of 363, and then I'm just going to press enter. Now, I'm going to look at this number a little bit more closely, and I'm going to see if it's repeating. Now, it does go on forever, but does it have a repeating pattern? No, it has 0, 5, 2, 5, 5, 8, 8, 8, then 3, 2, 5, and then another 8. This doesn't have a pattern. It doesn't repeat. So this is an irrational number. So you would go here and you would say that this is irrational. And then let's look at the square root of 27. So if I do the square root of 27, and again, let's look at this number a little bit more closely. It looks like it has decimals that go on forever. Does it have a repeating pattern? No, if you look at these decimals, they're all just random numbers, 196, 152, 422, 7066. These are just random numbers. So this is an irrational number as well. So we got two irrational numbers. So all we have to do is go 363 plus 27, and we know that these are both irrational. Let's just do the sum. So let's go and look at the calculator and see what we get. So I'm going to do control clear. So I'm going to take 363. I'm going to add the square root of 27. And let's see what it gets. We get 24.2871. Let's see. Let's copy it, see what it has. Okay, you can see that the numbers are going on forever, but does it have a repeating pattern? 24871130595. No, it's just a bunch of numbers, random numbers. So this is an irrational number. If you wanted to, you can put 24.2487111306 and then ... Actually, let's do it this way. I want you to see both of them. All right, so I just put the number here. I put the ... to indicate that this number is going on forever, but it doesn't have a repeating pattern, so we know it's irrational. Now, we can come down here and we're going to do the same thing, but we're going to be multiplying these two numbers. Let's see what we get. So I'm just going to copy this. You know, I like to, whoops. I'm going to copy this, and then I'm just going to change the plus to a multiplication, and then let's see what we get. All right, boom. So this is irrational. This is irrational. But this number definitely doesn't have any decimals, so this is rational. That's what we would say. And this would be 2 points if you do this. If you write IR, and then IR here, that's 1 point. If you do IR times IR and you get rational here, that's 2 points. And it's an easy 2 points. Use your calculator. Look to see if it has decimals that go on forever and no repeating pattern. That's all you have to do. I promise you. All right, I'm going to sign off and post this.